Hello everyone, my name is Joydeep Banik and today I am going to teach you the difference between Linux and Unix, monolithic kernel and kernel. Starting off with the first one, the difference between Linux and Unix. The first point under Linux is that it is free of cost and open source, meaning no restriction and no licensing fees. What do you mean by no restrictions? Is that there is no restrictions on the versions of different Linux. Okay, no restriction. Let me give you a cross. And also no licensing fees. So you don't need to purchase their license. Let me cross it. Whereas for Unix, they are proprietary in nature, meaning restrictions and licensing fees. What do you mean by proprietary? Meaning they are owned by a company. Simple as that. So what does this imply? Meaning they have restrictions meaning version restrictions. Let me give a tick for version restrictions, and you have to purchase the licensing fees. Not the licensing fees, their license. You have to purchase the license to use Unix. Coming off to second point, Linux uses a monolithic kernel but modifiable for different types of devices. Now what is monolithic kernel? Okay, I'm going to talk about it a bit later. Okay, but just keep in mind that it uses something called monolithic kernel, but it can be easily modified for different devices like embedded systems like Raspberry Pi, Android, iOS, or your personal computers or PCs. Unix, on the other hand, also uses monolithic kernel, but they are less hardware compatible, which means you cannot use them on embedded systems. Let me write EMB for short. You cannot use them on Android or the iOS either. Also, it does not mean that you can use them on your PCs. If your PC is powered by x64 or x32, okay, the 3 is like anything but anyways, let me just correct it. 3, okay, yeah, now it's okay. So if your PC has an architecture of x64 or x32, it's highly likable that your Unix won't work on that. They were originally made for x86 based systems. 86. Coming on a third point under Linux, Linux has a broad range of users, from personal desktops to embedded systems. Personal desktops like the mine right now, which I am using, Kali Linux for my personal desktop, and embedded system like Raspberry Pi. If you don't know, Raspberry Pi has their own Linux based operating system called Raspberry Pi OS. Whereas Unix are basically like generally used by academia meaning academic institutions, and enterprises meaning companies like IBM or Apple. Coming under fourth point under Linux is secure and updates are rapid and community driven. Under Unix is also secure, but updates are slow and depends on vendors. Now we all know what secure means, but what is this thing about updates? Why is Linux updates rapid and why is Unix updates slow? The reason is Linux is an open source community. Open source. Linux is not an open source community. Linux has an open source community. Sorry for that. Open source. Which means there are like hundreds, not even thousands of contributors working at the same time for the development of Linux. So let's say this is the total population. Okay, the not total population of developers. There are 100 developers in total. Okay, so each one of these 100 developers are working on the development of Linux. Okay, but in Unix, since they're owned by companies, let's say only 10 of those developers have the access to develop Unix, develop their updates, which means the update process is slow in nature. And there's also another reason why they are slow, because it ultimately depends upon the company. If the company wants to release an update, it will release an update. If the company wants, like, no, we won't release an update soon, we will release an update later, so there will be surely delays in an Unix update. That is the main reason the Unix updates are slow, whereas Linux updates are rapid. An important thing to note here, which many people confuse: Linux is an alternative to Unix. Okay, it's an alternative to Unix, but not a derivative of Unix. What does this mean? It means Linux shares the ideas and principles of Unix, but it wasn't developed on the Unix platform. It was developed as a separate platform. So although Linux shares the ideas, the principles of Unix, but it was developed as an free alternative to the costly Unix. So these were the key differences between Linux and Unix. Now coming to monolithic kernel. Now before we learn monolithic kernel, we need to understand the term kernel. Now what is this kernel? Kernel basically means the interface which connects the hardware with the software. So let's say hardware, we denote it as H, and we have software, we denote it as S. Let's say under software we have a text editor like the one I'm using right now, or the video editor, or the video recorder, anything. Under software you have a text editor, let's say. Okay, under hardware you have, say, an USB. USB has a hardware. Now let's say you want the file which you have created on a text editor to be inside this USB. How will you do that? If you say to the computer, okay, this is the file under the text editor which I have created, please put it inside this USB. But how will the computer understand your language? It does not have anything in the middle, right? So how will the computer connect between the software and the hardware? So here comes kernel. I'm writing K for short. Kernel acts like the middleman. Oh man, it's so difficult to write with a mouse. Okay, anyways, so kernel is like the middleman between the software and the hardware. It connects, okay, both the software and the hardware through itself. It's like an interface through which the software and the hardware can communicate with each other. It is like the brain of the operating system. Without it, your operating system won't even function. Okay, your operating system won't even function at all, because there is no link between the softwares on a system and the hardwares that are connected to the system. So kernel is a very important piece of an operating system. Without it, no such things will happen. So now we know what is a kernel. What is monolithic kernel? Let me just read the definition and then explain. Monolithic kernel is a type of operating system kernel architecture where the entire operating system, like core services, device drivers, file system management, memory management, process scheduling, runs in a single unified space called the kernel space. Now, there were a lot of things in this definition. The first is OS kernel architecture, the entire operating system, and unified space called kernel space. Now, what are these things? Let me give you a short example. Let's say, let me just scroll down. Okay, yeah. Let's say I'm drawing a visual representation of a Windows operating system architecture. Windows architecture. I'm writing Arch for short. Windows operating system architecture looks something like this. You have a space and these are called barriers. They're not called barriers, okay, but I'm just explaining it for the sake. They're not called barriers and there is no physical barrier of some sort, okay? Don't think like that. So anyways, there is this barrier between these units. Let's say it's unit 1, unit 2, unit 3, unit 4. So what does these units contain? These units contain operating system services like core services. I'm writing C for short, core services. File system management, F for short. Memory management, M for short. And drives, D for short. Now, in order for an operating system to work, all these four things need to communicate with each other. Communicate with each other. But there's a problem. The problem is these barriers. Okay, these barriers. So, how will these components communicate with each other? They will do context switching, which basically means they would just jump over the barrier. Okay, like as simple as it can be, they would just jump over the barrier. If the core services needs to communicate with the file system management, it would just jump over the barrier. If the file system management needs to interact with the memory system management, it would just jump over the barrier. If the memory management needs to interact with the drives, it would just jump over the barrier. Now, you would ask, okay, but why are there barriers? Why is this in a space and all of that? It's inside a space because, of course, it has to be inside something, right? The components of the operating system is inside the operating system architecture, and the architecture itself is kind of like a room of some sort where there are different components and there are barriers between them, and the only way to communicate for these components with each other is to jump between these barriers. Now, there are two direct results for the presence of these barriers. Is that your operating system becomes a bit secure in nature. So if something messes up in your core services, it won't affect your file system management. If something messes up on your file system management, it won't hamper your memory management or your drives either. So it's kind of like a fail-safe. So this is an advantage, but every advantage has a disadvantage. So what is the disadvantage? This jumping, which I referred to as earlier as context switching, makes this process slow in nature. Because to communicate with other components, the components itself would have to jump over a barrier and then communicate with the other component. So it kind of makes the process a bit slow. So this is how Windows architecture works. Coming to Linux architecture. Linux architecture. Again, Arch for short. In Linux architecture, you have the architecture space. But an interesting thing to note is that there is no presence of barriers, which means operating system components like core services, C for short, file system management, F for short, memory management, M for short, drives, drives, D for short, they are inside a single unified space with no barriers in between. There is no barrier, you can see there is no barrier, they are all together inside a room. So any communication between these components happens fast because there is no barrier, there is no jumping, which means context switching. So the processes become fast. This is one of the key advantages of Linux architecture. But there is a disadvantage to every advantage. The disadvantage is it becomes a bit less secure. Like there is an overall fail-safe, protecting the entire architecture space. This is the entire architecture space. There is a fail-safe protecting it. But if this fail-safe fails somehow and something affects, let's say, your core services, it would affect your file system management, it would affect your memory management, it would affect your drives simultaneously and consecutively. This is one of the key disadvantages of less secure. Now, this is another thing called kernel space. If I come back up to the definition, see this here, the kernel space. Now what is this kernel space? Since there are no barriers in this architecture space, it's an unified space. Like there are no divisions between this space, right? This unified space is nothing but the kernel space. This is called the kernel space. That is it. That's the key difference between Windows architecture and Linux architecture. I hope you understood this. So coming back up to the definition, I think you will now understand the definition. It's a type of OS kernel architecture. The entire operating system, like core services, device drivers, file system management, memory management, process scheduling, they run in a single space, with no barriers between them, and this single unified space is called the kernel space. Now key characteristics of monolithic kernel. As I said earlier, it has a unified memory space. There is no barriers between, therefore no context switching, and therefore faster execution. Direct communication, since everything operates under this entire kernel's unified kernel space, okay, this entire shaded region, and there are no barriers. There is a direct communication between the components of the operating system, and components can communicate directly, thereby increasing the performance. Third point is the same, high performance, since there are no barriers, therefore less context switching, and therefore monolithic kernels are fast and efficient. So this was today's video. I'm going to recap once again in a very short manner. The difference between Linux and Unix: Linux is free of cost and open source, no restriction, no licensing fees. Unix is proprietary, meaning restriction licensing fees. Linux uses monolithic kernel but modifiable for different devices. Unix also uses monolithic kernel but less hardware compatible. Linux has a broad range of users, whereas Unix is favored by academic institutions and enterprises. Linux is secure and their updates are rapid, whereas Unix is also secure but updates are slow. An important thing to note is Linux is an alternative to Unix but not a derivative to Unix. Linux does not come directly from Unix, it shares the ideas and principles of Unix. Coming to kernel, it is an interface which just connects the hardware and the software, and it's like the brain of the operating system. Without it, your operating system won't even function at all. Coming to monolithic kernel, it is a type of kernel architecture in which the entire operating system, core service, device drivers, file system management, and etc., they run in a single space with no barriers between them, called the kernel space. Key characteristics of monolithic kernel: they have a unified memory space, therefore allowing fast execution. They have direct communication because they operate under the kernel space, kernel space as of now. Therefore components can communicate directly, thereby increasing the performance. Monolithic kernels have high performance because of less context switching. This less context switching comes due to the absence of barriers, and thereby making monolithic kernels fast and efficient. This was today's video. I hope you learned something new in today's video. If you did, please make sure to like the video and also subscribe to my channel, because I am going to release a lot of videos soon. Thank you for watching my video.